Hi, doctor. My name is Zhou Chenbo, and my metric number is 227220. Now I will demonstrate lab 6 for you. Okay, for the step 1, we just make sure the the identify every configuration devices. And for step 2, we uh before deploying new features, it is crucial to clean up any leftover configurations. So we need to input this code to clean up. And we undo IP root state 0000 on router 1 and router 3 to delete the old stated default routers. And for step 3, Uh, because we are required to configure the standard IPv6 addresses on the point-to-point serial interfaces, then to connect the routers together. So we for R1, we need to assign IP address 10.0.12.1 to serial 001. Because as we can see, because the version of the ENSP is different and the document shows is serial 100, but because the different versions, the ENSP shows serial 001, but uh, even if they are different, but they are the same meaning. Okay, we come back. For the step 4, this step initiates the first phase of wide area network, and it's WAN, WAN, and encapsulation by slickly changing the link layer protocol to high-level data link control. That's HDLC using the link link protocol HDLC command and to connected the serial interfaces. And after we confirm the prompt with Y, we must draw back to the user view on R2 and execute ping commands to both 10.0.12.1 and 10.0.23.3 to verify that the layer 2 HDLC farming is functioning correctly over the direct point-to-point physical links. And this is a step 4. For the step 5, we need to achieve net-wide reachability. So we need to enable to open shortest path first, OSPF dynamic routing protocol by creating OSPF processes 1 and assigning the interfaces to backbone area 0. So R1 will advertise 10.10.12.0 network, and router 3 will advertise 10.0.23.0 network. And also, router 2 will advertise both networks, and once the OSPF neighbor adjacencies transition to the full state, and we should run a ping. We ping 10.0.23.3 from R1 to prove that the multi-hop dynamic routing is successfully established. And then we go through the step 6. Uh, after step 5, since serial cables inherently require one side to act as a data communications equipment, a DCE, to provide synchronization, so we must negative to serial 001 on router 1, which acts as a physical DCE provider, and then configure the clock frequency using baud rate 128000 command, and then we can subsequently verify this hardware parameter by executing. And after this, we can input display interface serial 001 to ensure the link speed has adjusted accordingly. And then for the step 8. Oh, for step 7, step 8, we transition the network encapsulation from DHLC to point-to-point protocol (PPP) by applying the link protocol PPP command on the serial interfaces of all these routers. Once that PPP point-to-point protocol is active, so we must investigate the routing table using display IP routing table on R2, and where we will observe a unique uh, characteristic of PPP, and it will auto negotiate and injects host routers for the peers interface IP addresses via the IP control protocol, and that's IPCP subnet negotiation. This is a step 7, step 8. And for step 9, we need to ensure the link between our router 1 and router 2 using password authentication protocol (PAP). So we must configure R1 as a authenticator by setting PP point-to-point protocol authentication mode PAP on its interfaces and creating the local user credential within the AAA database on the client side. Router 2 must be configured with PPP PAP local user Huawei password to submit these credentials, and we will verify the process by enable PAP packet debugging and bouncing the interface with shutdown and undo shutdown. And for then we come to final step. Oh no, step 10. This step shows the final state involves deploying the more secure challenge handshake authentication protocol (CHAP) between router 2 and router 3, where router 3 is configured as a authenticator utilizing PPP authentication mode CHAP and matching AAA user. So when we shut down and bring up the link, router 2 must present its CHAP, its CHAP credentials via the PPP CHAP user and the PPP CHAP password commands. And we can use debugging PPP CHAP all on router 2 to monitor the multi-step multi multi-step cryptographic challenge response handshake in real time, and concluding the lab with a final successful pin test across the entire topology. And this is step 10. Okay. Then let's go through the ENSP. This is a this is a configuration on ENSP, and for the this is a command for router 1. And then we this is router 2. This is router 3. Oh, we need to display current configuration. Okay. We display this is the current configuration. Then we display the router 2. This is router 2. Then router 3. Mm. Okay. So that's all for my lab 6. Thank you for listening.